we are given a function. It's a log function. You see ln models the wife's weekly housework hours, X years after 1964. It's all based on some data that they give us. Use the function to find the number of weekly household hours for wives in 2010. And use the function to project wives' weekly housework hours in 2025. So let's take it slowly. I have to write, this is problem 115 on page 491. And here is the function. We have f of x equals negative 3.52 natural log x plus 34.5. And it says that this is in hours, and x is the number of years after 1964. Number of years after 1964. So they're asking us in part A to find the value in 2010, the number of hours of housework that wives, according to the model, are supposed to perform in 2010. And then in part B, they want us to determine if the trend continues, assuming the function is still valid, what happens in 2025. Okay, so any suggestions of how to proceed? What does 2010 represent and what does 2025 represent? Yes? Anyone?
Repeat what you said.
Since x equals 0 for 1964, what will be x for 2010 and what will be x for 2025? So 2010 minus 1964, this is 46 years. And 2025 minus 1964, this is 61 years. All I have to do is I'm asked to find f of 46 and f of 61. So I'll have to put the function in the graphing calculator. Here it is. Clear whatever you had in there. So minus 3.52 natural log x, close the parenthesis, and plus 34.5. So negative 3.52 natural log x plus 34.5. And we go again to second and table, and we plug in 46, and we plug in 61. For 46, I got 21, roughly approximately 21 hours, and 20 hours. 20 hours for 2025, assuming the model still holds. So how many, we looked at two different applications of the log functions. Okay, log functions have three special properties that no other function has. So for the three properties of log, there are three properties. Here, yes, questions, please. Stop me if you have questions, anything. Anyone? Anyone? Yes? Anyone? Okay. So three properties. The first one is what is called the product rule. The product rule says that any log in any base, in other words, if I apply log to a product of as many factors you want. I just chose 2. That is the sum of each individual log. Log of x, log of y. No other function has this property. So here's an example. If I have log of base 10, let's say, of 3x, I can write it as log 3 plus log x. That's how the product rule works. Here is another rule, which is the quotient rule. The quotient rule is the same, just the quotient is, instead of a product, a ratio. What do you think the answer would be? If the product was a sum, what do you think the ratio would be equal to? Just a wild guess. Same thing but minus. Log base a of x, log base a of y. How will this work? Let's say I have log of 2 over 3. And this is the same with log 2 minus log 3. The quantity that comes from the denominator will always have a negative in front of the log. Negative sign. Final property is the power rule. The power rule says that if we apply log in any base, let's say to x, this is a power, whatever to a power, this power goes in front as a factor. Factor meaning it's a product. It will multiply log. So how will this work? As an example, let's say log of x to the 3rd power, 3 goes in front, multiplies log. There is also something called the change of base. Which is not considered a property. There are only 3 properties: product rule, quotient rule, power rule. And this is a change of base in the sense that if you ask me how much is log base 3 of 7, I will say I have no clue. It's y. I know how to change this into an exponential equation that we did before. 3 raised to y equals 7. But I still have no clue. I cannot tell you if this were 9, that would have been easy. I would have said 3 squared is 9, so y is 2. But you're asking me here to find a number that I raised 3 to get 7. I have no clue. And in most calculators, I don't have base 3. I haven't checked whether this one has something like base 3. I have not checked. Yes, I do. This calculator has an option of gives us the option of putting the base we want. So it allows me to put base 3 and then apply log base 3 to 7. And then press enter. It's going to give me a number. I could have never been able to come up with this number, 1.77 blah 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 blah, obviously. So this calculator allows us to put the base we want. But most calculators, or the ones that are older I should say, will not. Can I still find this? Yes, of course. So log base a of x can be changed into one of the 2 bases, not both, you don't need both. But you can use either the base log or base ln, because we have them. So here's the change of base, log of x over log of a. Log of the number over log of the previous base. This is base 10. We don't write it. So, or natural log x over natural log a. So how can I determine that number? Log base 3 of 7 is log 7 over log 3, or so log of x over log of the previous base, or natural log 7 over natural log 3. Not both. You choose the one you like. It's going to give us the same number. So let's try. Log 7, log 7, close the parenthesis, divide by log 3, close the parenthesis, divide by, and we get the same number. If I decide not to use this, but common log, but use natural log, that's still the same. Natural log 7 divided by natural log 3. Still get the same number. So this is approximately 1.7712. How do I check my work? 3 raised to this number should be 7. 3 power second and the previous answer. I want to take the whole answer. I don't want to use an approximation. And when I hit enter, I have to get 7. If I put the 3 to power this approximation, 1.7712, and I hit enter, I will never get 7. I will get very close, but not 7. But if I ask the calculator to raise 3 to the previous answer, I will get the exact number. And that's how the change of base works. And I know we have a few minutes left, but I would like us to use the properties of logs to expand. Just one example and I'll stop. So let's look at problem 21 on page 501. So this is log in some base called b of x squared y. And they want us to expand into simple logs. Okay, so let's see what I can do. I see that this is a product, first of all, and it's x squared times y, so this is a sum. First will be log base b of x squared, and the other one log base b of y. This is as simple as I can get it, but here I have one more property that I can apply. Bring the power in front. So this is 2 log base b of x plus log base b of y. No other property. We have 3 properties that we can apply. But no other property can be applied here. I apply the product rule and I apply the power rule. Any questions? Any questions? I think we have time, so we look at another. Yes, so let's look at 28, same page. In 28 we have log base b of x cubed y divided by z squared. Same question. We're asked to completely expand to simple logs. This time I have a ratio. I have to start with a ratio. So I have a difference of log applied to the numerator minus log applied to the denominator. So log of x cubed y, of course, in base b, minus log z squared, of course, in base b. This one will be very simple after I put the 2 in front, because I'm applying the power rule. But for this one, first I have to apply the product rule and change it into a sum. Log base b of x cubed plus log base b of y minus 2 log base b of z. Is there not extra step? Yes. This is completely expanded, simple, the simplest possible form, the simple possible form. But this one has the power rule that can still be applied. So then my final answer then will be 3 log base b of x plus log base b of y and minus 2 log base b of z. And this is final. Any questions? Any questions?
No.
But again, this is not part of this test, so let me know if you have any questions.
It's 4.3, right?
Yes, but we're not done. We still have work to do with that.
Right.
Anything? Any questions? I'm going to